Hello everyone, this is Vardman and welcome back. In this video, we are going to learn about linear search. Linear search is not an application of divide and conquer, but in order to learn binary search, you should know about linear search first. Let's look at the algorithm. For linear search, the input will be an array of n distinct element and an element x, and the output will be find the position of x if found, otherwise return -1. So we have to find if that element x is present in a given array. Let's take an example. So we have an array of 9 element and x is equal to 44. So we have to find if the element 44 is present in the array or not. Here we have our function linear search. It take array A, element x and size of the array n as input. Inside the function we have our simple for loop. So it will run from I equal to 1 and it will run until the value of I is smaller than n, which is the size of the array, and each time it is incrementing by 1. So this loop will just basically scan the array from 1 to the last element, which is 9 here. Inside the for loop we will check if the current element, which is a of I, is equal to x. If it is equal to x, then we will return the index I, and if we do not find such index where a of I is equal to x, then we will return -1 at the end. So here we can see the initial value of I is equal to 1. So we will go inside the loop and we will check if a of 1, which is equal to 55, is equal to x. So 55 is not equal to 44. So we will increment the value of I. The value of I will become 2. Now we will check if 80 is equal to 44. So it is not equal to 44. So the value of I will again get incremented and the value of I will become 3. Now 17 is not equal to 44. So we will again increment the value of I to 4. And here also 10 is not equal to 44. So now the value of I will become 5 and we will compare again. So 38 is not equal to 44. So the value of I will be again incremented to 6. And here 190 is not equal to 44. So the value of I will become 7. And here 64 is also not equal to 44. Now the value of I has become 8, and if we compare now, the a of 8 is 44 and which is equal to x. So 44 is equal to 44. So here we found the index we are looking for. So the element 44 is at index 8, and suppose if the element was not found at index 8 or at index 9, then the loop will be terminated and we will return -1, means that this element is not present in the given array. Coming to time complexity, so you can see this is just a simple for loop which is running from the starting index of the array to the ending index, which is the total of n times. So in the worst case, the loop will run a total of n time when the element is at the last position. So the worst case time complexity will be big O of n, and average case will also be big O of n, which is when the element occur at different position. It can be at the start, it can be at the middle, or it can be at the end. So the average case time complexity will also be equal to big O of n. The best case time complexity will be equal to big O of 1. It is when the element we are looking for is itself in the first position. So we do not need to scan the entire array. We will just return the index in the first iteration itself. Let's understand the coding implementation part of linear search. First, we have our linear search function. It takes in an array ARR the size of an array n and the element x to search as input. It then iterates over the array, comparing each element with x using a for loop. If the match is found, it returns the index of the element. If no match is found after the loop, it returns -1. Now let's look at the main function. We have defined the array ARR of integers. We then take the element x to search in the array. For now, we are taking the value of x as 10. Now we are calling the search function and we will check the result. If the element is found, it print the index. Otherwise, it will print the element is not present. We will run the program with the value of x equal to 10. So here you can see the output we will get will be equal to 3.